want to show you a couple of tricks that we used in class when simplifying expressions with exponents. So if we're going to apply the definition of x to the negative n, we know that that's equal to 1 over x to the n. So you could write it like this. Here's what I want to point out. If I had just written 5a over b, we know that that's the same thing as if you multiplied by 5 on the outside. So same thing here. I'm multiplying in the numerator, so that's going to be the same thing as if I brought it down here. And this is the same thing as if I just multiplied the numerators and denominators across. So where's this left us? We started off with an expression that looks like this, and we ended up with an expression that looks like this. What I want you to notice is you could have thought about this as just bringing that x to the negative n down into the denominator, but the exponent switched from negative to positive. Okay, so with I never want you to do an algebraic manipulation blindly. So let's take a look at this other side, because it wouldn't be you wouldn't be able to just bring this down into the denominator. But I want to make it clear why that's the case. The reason that it worked on this side is because multiplying in the numerator is the same as multiplying on the outside. So we could bring this thing to the outside, and that's what made us realize that it can move to the bottom here. The x to the n can move to the bottom. Well, here, can I do the same thing? Can I move the x to the n to the outside? What it would look like to move it to the outside would be this. But clearly that's not true, because if I was going to move it back to the numerator again, it would be multiplied, and here it was added. You might think, well, could I move it to the outside with an addition sign? But that doesn't make sense either, because here, both of these things are being divided by b. On this side, a is still being divided by b, but this is kind of magically not being divided by b anymore. So neither of those simplifications will work, because it just doesn't make sense to do them. However, as long as you are multiplying all the things in the numerator, it's perfectly fine to bring that thing to the outside and then think about the 1 over x to the n getting multiplied in the denominator. So multiplication is what lets you do this move where you can kind of shift it to the bottom. The other thing I want you to realize is you can do the same kind of move in reverse. So let's say I had x to the negative n down here. Let's rewrite this according to its definition. So this is like 1 over x to the n, and this is b. So remember that dividing by something is the same thing as multiplying by the reciprocal. So this is the same thing as saying a over b times x to the n over 1. And so now you can just multiply straight across the top. So again, I started here, ended here. I had x to the negative n in the denominator, and I ended with x to the n in the numerator. So you could think about it as just moving it up to the numerator and switching the sign from negative to positive. So that's kind of one set of simplification tricks. Okay, what about something like this? So this one, I can rewrite these as 1 over x and 1 over y. What if I wanted to clear these denominators? So I don't want to have a fraction down here, and I don't want to have a fraction down there. If I wanted to get rid of this x, well, let's discuss two different ways I could do it. So one thing I could do would be to try and combine these two by giving them the same denominator. So here I could multiply it by y divided by itself. The reason being is because I need this denominator to match this one over here. And then for the same reason, I'd multiply x over itself. So now this term has an xy denominator, that term has an xy denominator, and so I can combine them together. I can say y plus x is what I have here, y times 1 plus x times 1, divided by xy. And so that's going to be the same as xy times xy over y plus x, and that's the same thing as xy squared over y plus x. So that's one thing you could do. You could combine them to have the same denominator. Here's a different thing you could do that'll get you the same result. If I wanted to multiply by something to get rid of the x in the denominator, I could multiply by x down here. But I can't just multiply by x in the denominator, because that's changing what the problem is. If I multiply by x divided by x, That's just 1, as long as x doesn't equal 0. So that's safe. So if I was going to multiply across now, this x would multiply in here to give me 1. But over here, I'd end up with x divided by y. Well, let's do it in 2 steps. So we'll do this much first. So in the numerator here, I've got x squared y. In the denominator, I'm distributing this to both terms here. So x times 1 over x is 1. X multiplied there gives us x over y. Okay, how am I going to clear that y out? Let's do the same thing, y over y. So I'll distribute the y in. In the numerator here, I've got x squared y squared. In the denominator, the y times 1 gives us y. Y here gives us x. And so you see I've ended up with the same thing that I got with the other approach. I wouldn't have had to have multiplied in 2 steps either. I could have done it all in 1 step. So let's rewrite the original problem. I could have multiplied by xy over xy. The reason I'm multiplying by xy is not because of the numerator here. It's because multiplying by x is going to clear that denominator. Multiplying by y is going to clear that denominator. I want to clear both of them, so that's why I'm multiplying by both of them. So if I do that, here I've got xy squared in the numerator. In the denominator, xy times 1 over x just gives us y, because the x's divide. Xy times 1 over y, the y's divide, leaving just x. So again, we've got the same result. Okay, last one. So we had this problem. So you could think about this in 2 ways. One is, let's imagine this as blob to the negative 2, which we can rewrite as 1 over blob squared. So if I do that, I can rewrite this as y over x squared times 1 over y over x squared. And then this can join me in the numerator here. So I've got y over x squared divided by y over x squared, and that's just thing divided by itself, so that equals 1. So that's one way to think about it. Here's another way of thinking about it. Let's just look at the y over x to the negative 2. If I rewrite this according to the definition, it's 1 divided by y over x squared. I can rewrite that as 1 over y squared x squared. Okay, dividing by a fraction is the same thing as multiplying by its reciprocal. So that's the same thing as x squared over y squared, which is the same thing as x over y quantity squared. Okay, so let's look at where we started and where we ended. So here I had y over x to the negative 2, and it became x over y squared. So you can imagine that I just flipped the fraction upside down and made the exponent positive, reverse the sign of the exponent. So that's another kind of mental flexibility thing you can do when you're looking at these problems. Because when I look at this up here, what I see is aha, to the negative 2 means that I flip it, and now it's to the positive 2. And when I flip it, I notice that the y is in the denominator, and so y squared is going to divide by y squared, and x squared is going to divide by x squared, giving me 1. So not just, slowly and laboriously cranking along with the algebra. I think a lot of the goal is to develop some mental flexibility so that you can kind of see an expression and manipulate it in your mind and think, I kind of see how things are going to cancel. And it's not going to come all at once. You don't have to say, I definitely can do the algebra in my mind. But you can get a sense for, you know what, maybe this is going to be worth trying because it looks like something might cancel. And then you try it. It'll give you a direction to head in a problem where there might be many different things you could try.